Hey guys, welcome to your last lesson of the week, lesson 110. We are unbelievably close to the end of our book. It's making me a little, I can't believe it. But we're here, we're on lesson 110, Symmetry. Starts on page 573. So make sure you have your book ready, pencil, paper, whatever else you may need. And we're going to start with the mental math. Okay, so letter A is 90 times 90. What is 90 times 90? The answer is 8,100. All right, letter B, 726 minus 250. What is 726 minus 250? Answer is 476. Letter C, 50% of $50. What is 50% of $50? All right, the answer to that is $25. Letter D, we've got $7.62 plus $3.98. It is $7.62 plus $3.98. And the answer is $11.60. $11.60. Letter E, we have 8 divided by 100. What is 8 divided by 100? All right, so just sort of picture that fraction in your mind. That would be 800. So we would write it like this. 0.08, 800ths. Letter F, 350 divided by 50. What is 350 divided by 50? The answer is 7. Letter G, a circle has a diameter of 4 yards. What is the circumference? What is the circumference of the circle? So use your mental math here. If the diameter is 4 yards, what is the circumference? It's 12.56 yards. Remember, circumference is pi times diameter. And usually we let pi represent 3.14. Letter H, square 10 minus 1 divided by 9 times 3 minus 1 divided by 4 times 7 plus 4 divided by 3. The answer to that is 20. So a brief pause as this motorcycle drives by. Sometimes you guys can hear those, sometimes you cannot. So we'll just err on the side of caution. All right, let's get right into it. Symmetry. So a figure has symmetry if it can be divided in half so that the halves are mirror images of each other. Okay, we've got symmetry all around us. So basically every mammal has symmetry. So every dog, if you were able to draw a line right down the middle of the dog, it'd be the same on one side as it is on the other. You see it in butterflies. A lot of fish are symmetrical. So you see it a lot in nature. We see it all around us, where if you were to divide something in half or in other ways, there are different types of symmetry, that they'd be the same on each side. We also have manufactured items like lamps, chairs, kitchen sinks. Sometimes those are designed with symmetry as well. Picture frames. I'm trying to look around my room and see things I have are symmetrical. My fish tank has symmetry. If I were to divide that in half, I would have the same half on each side. A lot of things in our lives exhibit symmetry. And so two-dimensional figures, things that we can draw, also have symmetry. So if the line divides it into two mirror images, the image is symmetrical. In this case, we have a triangle, and it's an equilateral triangle. I'll tell you that right now. And I divided it in half with line R. And we see that the triangle is symmetrical because these two halves are the same. These two halves are congruent. And then this line R, the line that's actually dividing it, is called the line of symmetry, as you can see here. So it's the line that divides the figure symmetrically. Okay, so remember that. Symmetry is if we can divide it in half. We're just going to look at that type of symmetry. It's also called, and I'll give you a little... It's also called bilateral symmetry. It's when you can divide it in half, so exactly into two parts. Ooh. All right, let's keep going. Our first example, this rectangle has how many lines of symmetry? So how many ways could I draw a line through this triangle that would make it the same on both sides? Okay, so we could divide it in half this way. And we would have these two smaller rectangles. Of course, my line of symmetry isn't perfect. I just drew it freehand. We could also draw the line down this way. We sort of would have two squares. Okay, so this particular shape has two lines of symmetry. There are two different places I could divide it directly and perfectly in half. So I'm going to draw them both there. But just understand we wouldn't draw both of them at the same time. All right, example 2. So look at these three triangles. The question is, which of these triangles does not appear to be symmetrical? So in order to do this, we're going to draw our lines of symmetry. And one of the best ways to draw our lines of symmetry is to just choose one of the vertices and draw a straight line that goes through that vertex, wow, and is perpendicular to the opposite side. All right, so go through the vertex and go perpendicular to the opposite side. Through the vertex, perpendicular to the opposite side. So of course my lines of symmetry aren't perfect, they're just hand-drawn. But just looking at this, what triangle would you say does not appear to be symmetrical? Okay, let's label these. So you could say, oh, it looks like triangle. From this drawing, I would say that triangle C doesn't appear to be symmetrical. You see it's got a large triangle on this side and a much smaller triangle on this side. Triangle B is a little iffy, but that's just because of my drawing. You'll see I'm a little off from the vertex here. It's meant to be symmetrical. So you draw your line through one of the vertices, through one vertex, and then make sure your line's perpendicular to the other side. That's how you'll know whether or not we have symmetry here. Okay? Another term that I want you to learn is called rotational symmetry. So we're going to illustrate that on our next page here. A figure has rotational symmetry if the image will reappear in the position in which it started before a full turn. So remember, a full turn is 360 degrees. So in this case, we have a square. If I can start turning this square, let's start with original position. If I can turn this square in such a way that it's back to looking like it's in an original position before it has been turned 360 degrees, the image has rotational symmetry. So as you can see here, let's say this is our starting point. We turned it 45 degrees more. We're already back to the original position. Okay? If we keep turning this figure, look, we've got rotational symmetry again. Keep turning, okay? Oh, actually, it would be this one. All right, so we just turned it. So I'm just imagining that I'm turning the square at this point. So I turned it a little, and that's what this image is. We turned it a little more, it's up, it's there. Or I guess we're turning it that way. Hopefully you can visualize that, even though my little hand drawings that add to it are a little confusing. But that's rotational symmetry. So let's look at these four figures here, and I've already labeled them. Which of these has rotational symmetry? So if you could pick that rectangle up, if you could start turning it, would it get back to this original looking position before 360 degrees? So take a moment and do that with all four of those just in your minds and see if you could get back to the original position before you turn 360 degrees. Okay, so hopefully you'd see that rectangle A, or quadrilateral A, had rotational symmetry. Okay, I could turn it 90 degrees and get it back into its original position. How about figure B? Looks like I could turn that one 90 degrees as well. So if I turned it, or maybe 180 degrees, because 90 degrees it would be just upright. So for both of these, I would say you'd have to turn them at 180 degrees to get them back to their original position. For figure C, you'd have to do the full turn to get it back to where it started. If you turned it 360 degrees, it would just be upside down. It would look like this. That's not what we want. And the same thing for this triangle here. You'd have to keep turning it. So this would be one turn. That's not the original position. Another turn, it would look like this. You'd have to keep turning it to get it back to its original spot. Okay, so that was 90 degrees, 90 degrees, 90 degrees. So this one also took 360 degrees. So just A and B here have rotational symmetry. Okay, so we're going to jump right into our practice set. Just keep the terms in mind. Symmetry is if you can divide it in half, and it's the same on both sides. Rotational symmetry is if you can, while turning it, if you can turn it less than 360 degrees to get it back to its original position. Okay, so practice set part starts on page 370 or 575. Take a few minutes to work on that. All right, it says draw 4 squares. So remember, squares have the same side length. All 4 sides are the same length. So I'm going to make 4 3x3 squares. The next step is to draw a different line of symmetry for each. So you can think of the lines of symmetry we've used already for those 2 rectangles in our first example. Then the nice thing about squares is you can actually do a line of symmetry through diagonal vertices, and they would be the same on each side. Okay, so those are the 4 lines of symmetry, if you can sort of ignore my wavy lines. All right, practice set B. It says all but one of these letters can be drawn to have a line of symmetry. Which of these letters does not have a line of symmetry? So imagine you would draw a line halfway through these shapes, and they would be the same on each side, except for what shape? What letter? And that would be letter F. There's no place we can draw a line of symmetry through letter F. But through the rest of the shapes you could. So A, you could draw it down the middle. B, depending on the B, some of them wouldn't work like this. You could draw it down through the middle like that. C and D you could do through the middle. E as well. But not F, because it's not E. There's not another line down here. You can draw it this way. All right, so there's no line of symmetry for F. All right, letter C. Which of these 2 letters have rotational symmetry? Hint, rotating the book might help you find the answer. So that's actually really great. Just hold your book up, start rotating it. See if you can see any of those letters normally without turning your book all the way around. All right, and hopefully you'll see that with letters N and letters O, you don't have to turn the book all the way back to its starting position to see those letters in their original position. Okay, so hopefully you guys enjoyed this lesson on symmetry. Remember to look at your homework in the description box, back on Google Classroom, or of course in GradeLink to find your homework. Even though I have it written here, I didn't write out all the numbers. So look elsewhere for that, but it's there. If you guys need any help, please let me know. I'm always here for you. All right, thanks guys. Have a good weekend.